This is a video on how to solve 2D collisions. Let me introduce to you how these problems work. So if you have a billiard ball A and it's moving at momentum P, let's say it crashes into billiard ball B, but the collision's not head-on, so they fly off at different angles, with A flying off this way and B flying off this way with their own angles. Because momentum is a vector and momentum is conserved, the x components and the y components of momentum are also conserved. Now, the conservation of momentum says that the total momentum before is the same as the total momentum after. Let's apply this to the x component. So the total momentum before would be the momentum x component of A, which is this, plus the momentum x component of B, which is nothing since it's at rest at the start. This would be equal to the x component of ball A after the collision. So we'll denote that with a prime, like that. That is this part of the momentum vector, plus the same thing for B, which would be this. Since this is at rest initially, we don't have to consider that at all. And let's make some space. Because momentum is mv, then we can rewrite this equation as MAVA equals MAVA of cosine A, which is plus the same thing for B. Now, if you're confused, don't worry. I'm about to explain it all. Let's break this down. So when you break a vector into its x components, you use cosine. All we've done is turn momentum into mv. And then we use cosine. And these are primed quantities, which means the velocity after the collision and the angle after the collision. This is the formula that you use when you apply the conservation of momentum to the x component of a collision. And this is hard to remember. This is a big fat formula, so it's in the cheat sheet I made for free in the description. The y component, we do a similar thing. Initially, the y component is 0 because the ball is going horizontal. There's no vertical movement yet. That means the left-hand side of the equation is 0. The right-hand side will do the exact same thing as before, but we'll do it with sine, since it's the vertical component. And the two equations that we made right here for the x and y components, this is two independent equations. That means we are able to solve for two unknowns. So we can solve for the y component and the x component, and then we can find the path of momentum that our object takes after a collision. Let's put this all into practice with a practice problem. Let's say you have two roller skating girls. You have girl number A, you have girl B. And girls have hair, so let's give them some hair. Girl A moves at velocity of A. Girl B is stationary, and girl A is moving toward girl B. And they collide, they crash into each other. Girl A flies off at an angle of 45 degrees in this direction. Girl B does the same thing, but in the other direction, at the same angle. And this is all relative to the x-axis. So because A is going above and B is going below, then the angle of A after the collision is 45 degrees, but the angle of B after the collision is negative 45 degrees because it's going down. This is our problem. What are their final speeds after this collision? Let's assume there's no external forces on our system, so the conservation of momentum applies. Because there's two unknowns we're looking for, which is the velocity of A, the velocity of B after the collision, that means we need two independent equations, which will be our y component equation and our x component equation. Before we start this problem, I want you to hypothesize what are the girls' speed. My assumption is that they will have the same speed. But in math and science, we cannot assume anything. Let's solve our problem. So let's use the equations that we just created, which by the way are on the cheat sheet in the description for free. I'll quickly write them out. Great, there we go. Since they have equal mass before and after, and because their mass is also the same between each other, let's cancel that. And remember, what are we looking for? These two values. So let's choose one to solve for. Let's isolate the velocity of girl B after the collision for her y component. You can actually choose any of these, but let's use this. Our new y equation after cancelling mass looks like this. Rearrange for velocity B, we get this equation. If you recall from trigonometry and trig identities, then sine negative 45 is equal to negative sine 45. So our equation can be rewritten, simplified, like this. Any number divided by itself is equal to 1. And since it's negative, that means sine 45 over negative sine 45 is equal to negative 1. Which means that our equation is negative VA times negative 1. Which gives us positive VA. So that means our equation is velocity of B is equal to velocity of A after the collision. Which means that yes, their velocities are equal. Our hypothesis is correct. Okay, cool. What about the x component? The x component says that VA equals VA after the collision cosine 45 plus the same thing for girl number B. Now cosine of a negative number is equal to cosine of the positive number, which gives us this. And because VA and VB are equal, we can just write both of these as VA. So this simplifies to 2 times VA cosine 45. We're going to go ahead and solve for this value by moving these two to the other side. From this, we get VA after the collision is equal to initial VA over 2 cosine 45. Now, if we want a real number from this, let's just say the girl was skating initially at 5 meters per second. Then our answer is roughly 3.5 meters per second after the collision. And because VA is equal to VB, this value is also the speed the other girl goes at after the collision. Here's something interesting. On top of these two equations, the x and y equations that we found, if the collision was completely elastic, then kinetic energy is conserved, which means that we would be able to get a third equation to find a third unknown if we had to, which would be the kinetic energy conservation equation. By the way, something that really helps me is having all the formulas you ever need in one place. And I make these cheat sheets for myself, and if you want your own, it's in the description for free. So go sign up.